Welcome to AM Best Audio.
This is William Borden for AM Best Audio. We spoke with Hari Balakrishnan, a computer science professor at MIT and the chief technology officer and co-founder of Cambridge Mobile Telematics. The company received an investment in March from Allianz, State Farm, and the Rise Funds, an affiliate of the private equity firm Texas Pacific Group. The company's technology is used in more than 50 million vehicles, and the new investment is seen as an opportunity to expand the adoption of this technology that can have a major impact on auto insurance underwriting and the development of a universal driving score. Thank you for joining us. So could you tell me a little bit about yourself?
Sure. First of all, thanks for having me and talking about CMT and telematics and road safety. So my name is Hari Balakrishnan. I'm a co-founder and CTO of CMT and also chairman of the board there. In addition, I'm a professor of computer science and AI at MIT, where I've been for over 25 years and started CMT with a couple of other co-founders, Bill Powers and Sam Madden, based on research that I had led at MIT prior to starting the company.
Now, this kind of research, does it date back to your PhD program when you were trying to make your way into academia?
Not quite that far, although my PhD thesis was in the area of wireless networking. Predates Wi-Fi. It was in the late 90s and worked on technologies that eventually became things that showed how to get high performance over Wi-Fi networks. But subsequent to that, I came to MIT in 98 and shortly after started a project on sensor computing with building a very accurate indoor location system called Cricket. The idea was to get a few centimeters of accuracy indoors, and it used innovative sensor technology with ultrasound and radio. About 5 years of that project, and I'd gained a lot of experience with embedded systems. And my colleagues, Sam Madden had joined MIT in 2004 from Berkeley, and he had worked on a sensor computing data processing platform while at Berkeley. So in late 2004, by that time we'd left Cambridge where I was taking the train every day and moved out to the suburbs. And what had happened was I was finding that traffic patterns were quite unpredictable. And out in the Boston area in the winters, it would take longer to get to work, but also the roads were, right after the winter, the roads were pretty bad. So I had this thought that we could take our sensor technology, not the ones we developed before, but just these ideas from sensing and put them on vehicles and build both embedded devices and things like old style Nokia phones and things of that nature. You have to recall that 2004, 2005 was before the iPhone, before the Android, before all the stuff that we completely take for granted. And the young people listening, you should ask your parents what that means. So one of the things we had built, and this project was called Cartel. I did not know the word telematics at that time. It was called Cartel because it was an easy word, car for car, and tel was really for telecommunications, or tele something. And so it became a really successful project because Cartel, we ended up showing how to create this field of mobile sensing, which in industry is today known as telematics. The idea of equipping mobile assets with sensors like accelerometers, gyroscopes, GPS. And it was innovative at that time. In fact, I was looking back through some material, and the first embedded device that we had built attaching to vehicles at the time cost over $500. And today we have, CMT builds, I would say, more capable devices at scale. We've shipped over 53 million of these types of devices to date that are, many, many, many times less expensive. That shows both the innovativeness of what we've been able to do with the technology, but also just the way in which over time technology costs come down.
Is this Moore's law playing itself out in telematics, Or is this more of an innovation cost pattern like genetic testing, where the first genome was billions of dollars about 25 years ago and now is less than $1,000?
Yeah, I would say it's a little bit of both. It's probably not primarily Moore's law, which in many ways has kind of ended. But these platforms are really the telematics platforms combine three things. They combine processing, sensing, and communication. So you need all three. And I think I would say the biggest factor in commoditization, two big factors. First and foremost, the advent of the smartphone at massive scale, which means if you build not millions, but billions of these devices, and they all have these sensors on them, the costs come down with scale. And clearly, there's a lot of manufacturing advances that have happened, miniaturization advances that have happened. And frankly, the idea of MEMS sensors is just mind blowing. The fact that you could actually build these sensors and have them work even with remotely, with the type of precision that they have at such low cost is just mind blowing. So I think we benefit a lot from that. And then the communication as well. Just the idea that you could do low power embedded communication in really small form factors is, again, real, kudos to our hardware colleagues for being able to produce that. And when you take all of that together, and the second part is the software capabilities and embedded firmware capabilities that we're able to put together and use AI-based algorithms to deal with noisy data. I think that when you combine all of that, you get what we see today. But going back to the 2004 to 2010 timeframe, what happened there was it was before all the iPhones and the miniaturization that we take for granted today. So we built some devices, the first car was actually one of my car, and then we scaled up to like 10 cars. And then eventually one of my postdocs in my group, two guys, one of them, Louis Girard, has been with CMT since day zero of the company. And the iPhone had just come out in 2007. In fact, Sam Madden, my colleague, he and I wrote an app called iCartel. He did most of the work on the app. It was the first crowdsourced traffic app. It predates Waze and predates all the stuff that you take for granted today. And it used GPS and accelerometer data. So we knew we could do it on the iPhone, but you couldn't do it in the background in those days. But we placed a bet that Android and iPhone would allow for the capabilities of background processing. And we also had Louis Girard on our team, and to date, he still remains to me the world's best engineer of IoT technologies in the mobile space, in the automotive space. And we knew that if it could be done, he could do it. So we kind of set out on this path of learning how to think about insurance telematics, what today is called insurance telematics. And we were fortunate enough to have some early partners who taught us and explained to us what the problems were, and we tried to solve those problems.
Now, you mentioned the earlier incarnations of this technology. I mean, like the plug-in diagnostic things, and now it's all phone-based. As you get deeper and deeper into gathering this sort of data, I mean, beyond fast braking or speeding, how is that useful to the insurance companies by going more granular with what information you're gathering?
That's a great question. I would decompose the evolution of this technology into two topics. One is, where does the data come from to measure people's driving? And second, what inferences can you draw from it? And what actions could one take, both in terms of the insurer themselves and in terms of what the driver can do with it to get utility from it or improve. In terms of the data sources, we have this hypothesis earlier that technology is going to evolve and there are going to be many data sources. But I think now, over the last 5 years, I think it's become very clear that there is not a one size fits all. There are going to be people who will use an app together with a tag type of device, an IoT device. And increasingly, we're seeing that there are people using pure IoT devices. That could be a standalone tag device of the type that we're building now, or it could be an OBD device. In fact, The main thing about that one has to keep in mind are the main things. There are three things that one has to keep in mind. Number one, what sensors are on the device that you're collecting. And it could be anything from an accelerometer alone to accelerometer and a gyroscope and a GPS, and there's a bunch of sensors. Number two, what's the communication plan to get the data out and to get back and upgrade the software and things of that nature. And the third is relating to kind of where the power source is. What's the energy consumption model? Is it a battery? Is it plugged in? Is there a charge? A wire, a cable, etc. And of course, all of this has to be done economically. And of course, in the commercial and fleet context, the price point could be higher because those vehicles are driving a lot more and there's more value. For the personal lines, it's got to be a much lower cost. Then there's the question of the insights. And in the early days, it was pretty much about amount of distance traveled and heartbreaking. Those would be probably two key factors. But increasingly, in fact, over the last 10 plus years, as the data provided by companies like us are quite granular, there is a plethora of factors that could be used. I mean, one is phone distraction, which...
Customize your data experience. BestLink now offers an interactive company dashboard that provides company-level intelligence in a fast, user-friendly interface featuring interactive tables, charts, and Sparkline performance histories. Customize the dashboard tiles to prioritize the insurer ratings, data, and analytics that best support your workflow. AM Best. Our insight, your advantage.
Of course, with an IoT device, you don't get, but you could estimate phone distraction by building AI models that look at how people are. We have models that look at how people are tapping the phone. We don't know what they're doing, but we know the patterns of distraction when your eyes are off the road, with the amount of rotation of the phone, for example, or tapping patterns on the phone, just purely based on the algorithms running on just the accelerometer type of data. But that is evolving now into something that CMT has recently developed, which we're really excited about, called a foundation model, which allows you to get out of the business of the humans trying to find interesting patterns and factors that you might have a hypothesis, right? Well, you might think, well, maybe somebody swerving in a particular way is risky, and you might then go and collect a lot of data and have some ground truth and labels and train a model to detect swerving and then figure out how risky or safe swerving might be. And you can do this continuously. In fact, it employs lots of us in the data science area. But one of the things that's happened with modern AI is that machines are actually pretty good at finding patterns themselves. And we've seen this happen with natural language, where things like ChatGPT and Gemini and Claude are really good because they have found patterns in language. And people are doing this for video data. You can see video generation, and people are doing it for images, and now for radiology and medical data. So we've done this for telematics sensor data. And it turns out algorithms, AI is able to find patterns in the data that are frankly beyond human imagination. But yet, when you combine that with natural language, and we call that whole system drivable atlas because it allows you to navigate it, you can actually understand and attribute kind of human understandable explanations to patterns that the AI has found. And so what that does is it really elevates the level at which insurers, the actuaries, and others in insurance companies can use these patterns, because now they have dozens and dozens of these patterns, and they can start to do the work of combining them and associating safety or risk elements, factors with those patterns. So we don't have to any longer be limited by our A, imagination, and B, collection of massive amounts of labeled data for every specific little pattern of driving.
I think this is interesting because on a certain level, does this create a situation where insurers don't need as much demographic data to gauge that risk if they have a driving history attached to a particular driver, and you can almost use AI to predict a driver's behavior in the future?
I think that's a great question. I think that that is the type of analysis that I think we and our partners especially are in a position to start doing now. There are some advantages of that. Number one, I think it provides drivers and policyholders, I would say, probably a greater sense of control and equitability. In other words, I have two daughters, and they're actually very good drivers. They use, telematics apps that are from our insurance provider, and objectively, they're actually the two best drivers in our family compared to the adults in the family. And that is true based on the data. And of course, yet our premiums are a lot higher because statistically, people in their demographic are a lot, are more likely to be in a crash. But there are obviously exceptions. And I think personalization and individualization works. In fact, they react very well to the feedback and the rewards that they get, or in terms of becoming better drivers. So, and moreover, these telematics factors are often controllable. You can control the degree of risk, whereas it's very difficult for someone to control their age or other their gender. I don't think we use gender, but I know that age is used. I know that number of years of driving is used, and a motor vehicle record with the number of traffic tickets is also used. And interestingly, traffic tickets are a very sparse signal, and they're not really uniformly applied, right? There are parts of the cities or states where, where are traffic tickets given? Well, they're given more where there are more enforcers, and it's totally not uniform. So I think that in that sense, using such factors derived out of telematics, especially with the more modern AI techniques, have two benefits. Number one, I think they are more predictive. They're already the most predictive factors, but with these, I think they become even more predictive. And B, I think they're far more controllable by the driver. Now they can start to actually demonstrate being better drivers. And that includes even changing driving habits. It may be that they avoid driving through risk-prone areas because the technology tells them that at these times you shouldn't use this road, but use this other road. And I do believe that I don't want to stand up here and say that it can totally replace demographic factors, but I am going to stand up here and say, or sit down here and say that it is an analysis that is absolutely worth performing, and we and our partners have the ability to do that because it provides a far greater degree of control and predictivity to an insurer.
And I guess now, one of the items that CMT is looking at is also helping to establish a universal driving score. Could you explain what that means to the listeners?
Absolutely. One of the holy grails of the business in the insurance business is a kind of the idea of having at point of quote, the idea of having some sense of the history of driving, or a score derived from the history of driving. So you as a customer seeking insurance can present a score or present some data, and the insurer can use that to determine whether the rate that could be offered to you. And today at the point of quote, very rarely is telematics used. There has been a move to obtain this data from connected vehicles, and that in some cases has run into roadblocks related to drivers not having perhaps provided the consent or thinking they didn't provide the consent, and there's been some press articles about that. So our concept is to provide the driver, to have the driver in control of it's their data, it's their driving, and to provide a variety of mechanisms. Initially, it would be an app, and the app would allow people to obtain the a driving score, which would then get presented with their consent to insurers. And the app would also tell the driver how they could improve their driving in order to get a better point of quote type of score. So you could think of the universal driving score as a passport that is yours as a consumer. It's yours and yours only.
Yeah, and how would you say this approach fits into a model toward loss prevention when it comes to the insurance sector? How would you say that?
Yeah,
how that fits in general?
Yeah, that's a great point. I think loss prevention is something that is super critical, and especially with a mobile-centric approach. And I don't mean for data collection, but I mean engaging drivers with a mobile app. I think it really improves their awareness of good and bad things about driving. We've done a lot of research on this. So one of the things we found is that when drivers are engaged in a telematics program, by which I mean if they look at the app to see their feedback 2 or more times a week, those drivers are 65% safer, i.e., they have a crash frequency that's on average 65% lower than other drivers. And we've also written a paper that's peer reviewed and has appeared that you might ask, well, is it that safer drivers get good scores and they're more likely to look at the app, or are by looking at the app and getting feedback, do you become safer? Like, in other words, is it correlation or causation?
Is there anything else you want to say before we go?
Yeah, the one thing I will add is, we talked about measurement, which allows insurers to match price to risk. We talked about prevention, but the third one is what happens if you do get into a crash. So telematics also enables real-time crash detection. We have, again, millions of drivers every day that are being protected by this. And one example is an app we have. It's a free app called Open Road in the US. You get free crash assistance with telematics from an app. But many of our insurance partners, State Farm, Progressive, and many others, offer this in their main insurance programs, in their main app. And so that's a free benefit, which is great for peace of mind, to keep to be safe. So I would say that that's an area that is also extremely useful from the perspective of both policyholders and the insurance company, because if they detect the crash first, then it benefits the insurers, because then all of the things like towing and so forth can be done in network. And overall, the time to get the vehicle, first of all, it saves lives. We've got feedback from individual users that literally says, this app saved my life.
Thanks for joining us. This is William Borden for AM Best Audio.
Looking to get the full attention of the insurance industry? We have the platforms that will do just that. Whether it be AM Best TV, AM Best Audio, Best Review Magazine, or Best Day. Find out more by calling AM Best Advertising Sales at 908-439-2200, extension 5399, and have a great day.